before we start, maybe I can entertain you with some few questions, some show of hands kind of stuff, second grade thing. Who has downloaded Llama 2 and played with it? The Facebook Meta new model. 1, 2, 3, or was like almost a 3. All right. Who has played with ChatGPT's, not the interface, but the actual API? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my God, it's a good team there. I'm waiting questions. Perfect. Okay, thank you. Let's actually test this and see if it works. Well, nothing is yet on the... Cool. All right, so I know you haven't heard about MetalSoft. MetalSoft is a relatively new company. I'm going to talk a bit about it later. But it's okay if you haven't heard, right? That's what I wanted to say. But today's topic is going to be about, not about LLMs per se, the LLMs themselves, as much as the infrastructure that you need to run LLMs privately, without the cloud, without our friends at Google here with Colab, or OpenAI, or any other sort of cloud service. And the reason for that is because there's a lot of companies that need to run things privately. Now, this is open for debate, right? So we're not debating why do you want to run them private. Some people want to run them because they fear that uploading their data to the cloud, may mean that the cloud vendor will train their, models on them. Or others may fear that's financial data or some secret access to environments or whatever. So there are many reasons for which we want to do this. And fortunately, now we have options, right? And so you may be looking to build your own infrastructure or your own cloud service that requires an LLM, and it's a very cost-dependent service, right? So for you, it's important. The cost per token is important, and what you get from a cloud may not be good, right? So I don't know. So there are multiple reasons. Again, we're not here to debate that, but if you are one of those people that want to build something like this, chances are you're working in this larger organization, picture a bank, or some other financial institution. You have multiple teams, right? So you have, team 1, team 2, and team 3, and they all want to play around with LLMs, and they all want GPUs, and they all want, access to very powerful hardware, which costs a lot of money. So the question then becomes, how do you allow them to do that in a cost-effective way on-prem, and without having, many engineers plugging cables and, moving things around and configuring IPs and allocating, VMs, deploying operating systems, and doing a lot of things like that. So, and obviously, if you're into this business, one typical solution is, well, we have this VMware cluster or KVM cluster, and we're going to just give them VMs and map GPUs to the respective VMs, which is okay, but a lot of these workloads, they really do require bare metal access. So direct access to GPUs, direct access to RAM and CPU and memory, because it's all about performance in the end. And so that's the problem, right, that we're trying to solve. So what MetalSoft does is that we're this software layer, this blue layer here, that you put on top. I'm going to try to stay on this other side. That you put on top of hardware, right? And it's a software. It's an orchestration software that provides a bare metal as a service to the upper layers. Right? So it's all it does. It's not directly related to LLMs per se, but in this particular scenario, we're using it to provide access to the various tenants, to the various teams that I've spoke about before, to various tenancies. Right? So you have a group that builds some LLMs using one model and using Torch Serve for serving the model and some additional vector database. And so that's a stack. You have another team doing another stack, and have another team doing another stack. So what we do is we help you allocate these resources and shift them between the various groups by orchestrating the servers, but more importantly, the network component. So I'm going to show you in the demo later on, because we actually have relatively few slides. We're going to show you how you can do that. But basically, you have this drag and drop interface, and you can say, I want this server and connected in this network. And you hit deploy and gets deployed from the common pool of resources that you build from your resources, basically. So, on top of the bare metal as a service, you can run anything that you would typically run on an infrastructure as a service offering that you see in a cloud or maybe on-prem. All right, and I said I'm going to talk a bit about MetalSoft. So MetalSoft has been, it's a software company that was spun out of another company called Big Step, which you may have heard of. It's a service provider focused on big data. And it was a software that we use in Big Step to run the operations, right? So it's a service provider software. Anyway, so in 2019, we spun it off as a separate entity, and we're now selling it to the wider audience, and we have a lot of customers actually that are now using it to orchestrate their bare metal. With various other use cases, primarily this return from the cloud, not necessarily return, but sort of using more on-prem than before. As a parenthesis here, it's a IDC is saying that last decade has all been about cloud first, but this decade is going to be about cloud when it's needed. Just, yeah, I thought it was interesting. It is due to the costs of cloud in general versus on-prem, which people have started to realize it's not that, efficient to run, especially for certain organizations, not all of them, but for certain organizations, it's hard. Anyway, so why would you want to run private versus public LLMs, right? And what's a private LLM in the end? Well, you know about ChatGPT, Google Bard, Claude, Cohere, the Mistral one that was just released, which is actually interesting. Oh, sorry, Mistral is here in the private LLM side. But anyway, these ones are LLMs that you can access as a service, typically proprietary. And these ones here, starting with Llama, which I think is the most widely used, but there's others. Stanford Alpaca, Mistral, like I mentioned before, which are models that you can download, right? You can download the neural network parameters for each synapse and run it on your own GPUs. Now, there are ways of running private LLMs without having your own infrastructure, right? So you can take a Llama 2 model from Facebook and run it in a private model as a service offering from some cloud provider. So most recently, Amazon Bedrock. You've heard something about it, I think, in the news this morning. So you can use Amazon Bedrock to run your own models. Hugging Face has what? Have you used Hugging Face? Cool. All right, so yeah, I love Hugging Face. Anyway, so they have these inference endpoints that you guys know about, and you can use it to host models. I haven't tested it with Llama 2, though. Not sure if it works. I guess it does. And then Google Vertex. That's also a service that you can use to run your own models. But that's sort of halfway in between, right? Between a proprietary model and it's still consumed as a service, but it is your own. So for a certain organization, this is going to be the best solution, probably, to have that ratio between private and public. Especially if you are training your own models, your really private models, like the Bloomberg GPT, for example, or if you're Ernst & Young, if you want to build your own model and you want to make sure that it's your own IP there and you don't want to share it with anyone, this will probably want to be one of the solutions if you don't want to actually host it yourself. Anyway, so we're going to talk about the on-prem hosting part, right, where you actually have some hardware. And I'm going to show you some numbers. How much hardware you need, and also how much it costs. But first, how do they compare? Right, so, because we've been playing around, I've been playing around with some earlier generations of Llama, and they were really bad. I'm not sure what your experience was, but mine wasn't fantastic. But this Llama 2, the second generation, is starting to become a little bit better. So this is a human in a summarization task. Right? So this is a human. You can actually see something here? Okay, I cannot see anything. The pixels are too big. Anyway, so this is a human. This is ChatGPT 4, which is a little bit more than a human, which I think is interesting. ChatGPT 3.5, Llama 2 70 billion. Right? So the Llama 2 has, for those of you who don't know, comes in 3 flavors. 7 billion parameters, 13 billion parameters, and 70 billion parameters. And these numbers are not arbitrarily chosen, and I'll explain a bit later. But anyway, so this is the biggest Llama 2, the 70 billion one, and it's very close to ChatGPT 4 in terms of performance for at least these summarization tasks. ChatGPT 13 billion is not that bad, actually. It's close to 3.5. But Llama 7 billion, at least in the summarization task, it's pretty bad. So, just an order of magnitude of how close they are with, the gold standard today. Now, I've told you about the 3 versions: 7 billion, 13 billion, and 70 billion. So the reason why these are like this, and this is most of the models that you see in Hugging Face, they have these numbers attached to them, the number of parameters, which obviously are important because they tell you how much memory you need in your GPU or your RAM to load them. All right, so in this 7 billion one, the smallest one, which I'm going to play around with it a bit today, if we have time, that needs about 14 gigabytes of video memory. So it fits into a relatively small GPU. If it's the original version that you get from Facebook, which is 16-bit per value of a synapse, right, per value. But there are mechanisms, for those of you who probably already played with it, of shrinking the model and making it smaller by eliminating some of its resolution. Right? So going from 16-bit to 8-bit for each synapse and then 4-bit. And obviously the size decreases, but the precision also decreases. Right? So the model, it's not the same model. It becomes a little bit less precise. Especially the 4-bit one or the 2-bit ones, they are not very good. But 8-bit, it's pretty good from what I played with and what I've read. Unfortunately, there's no way of saying that these numbers are, in terms of performance, which I'm going to show you a bit later, are absolute numbers, because for each task, for each prompt, as you know, for each prompt, you get a different answer, and your mileage may vary, as they say in the US. Anyway, Llama 2, 13 billion. This is also interesting. So what's cool about this, this fits into the, what we have. I have P100 GPU, so it's at that 16 gigabit mark. So you can fit into that type of GPUs, which is a lot of them. You can find a lot of them on the market, and they're not expensive. 26 GPU, again, you can fit into one GPU that is more expensive, but still relatively easy to find. But this one will not fit into a GPU for sure, right? It's 140 gigabytes, and I've seen some A100s that have 80 gigabytes, so maybe they could fit in 2, but probably very, very expensive and also complicated. But this is the one that you may be after if you want ChatGPT 4 type precision and efficiency. And I'll show you a bit later some numbers. All right. So again, can you do it without GPUs? It's a question that that I asked myself, because not everybody has GPUs. And if you order a server today from Dell, it's going to take you a year until you get it. So maybe you want to do stuff on CPUs, because you may have some servers running available. So, and that's actually quite, it's possible. It's not that bad. So this is a sort of a relative tokens per second relative performance of each of it. And if you have a CPU or 2 CPUs with 24 cores, in total you get about 2, 3, maybe 5 tokens per second. Right? So it's not, and it's going to take some time until it loads everything up and then it outputs the data. And then this is the one that we have in the lab, and we can show you. It's not very far away from the CPU, but still better. A40, much better. A6000, again, much better. But it's not an order. I mean, it is an order of magnitude. It's almost 10 times faster. But I think for some research applications, you could be OK with just CPUs. But again, it really depends on the size of the model. And you need to have enough RAM. So if you want to run the 70 billion one, you need to have at least 255, like 160 gigabytes of RAM to be able to load the model in memory. Otherwise, it's not going to work. Or you might want to try quantizing it. OK, so how much it costs? Well, I did some simulations today, this morning, actually, on Dell's website on how much it will cost. And I put together some configurations, a small, a medium, and a large one, to give you an idea of how much money you would need to have. I mean, not you personally, but your organization, right? If you want to build something like this. And how much it will cost per token, per 1,000 tokens. And I can get into the details of how the math was done if you're interested. Again, your mileage might vary because this numbers of tokens depends also obviously on the prompt in general. Okay, so so if you have a server without any sort of GPU, right? So just a server, the regular server, but a relatively beefy CPU that has 64 cores in total, physical cores. So hyper-threaded will be like 128. Not a lot of RAM, so 128 gigs. So you may be OK with playing with smaller models. Some disks, and you get 3 of these, some switches, some out-of-band switch, and 5-year worth of collocation. Who knows what collocation is? So, OK, cool. So collocation is basically a service offered by a data center vendor. So when we talk about private infrastructure, it doesn't necessarily mean you have to keep it under your desk. It doesn't have to be in your own data room or data center that you operate. You can rent space from a vendor, and there's many, many vendors, and it is what the hyperscalers are doing. You just rent the space in a rack, like a 1U space to put your servers in, and a private cage or a private location in a data center. And there's plenty of such data centers out there, Equinix being one of them, maybe the most well-known. And anyway, so you get some, it's 50 euros or thereabouts per month to host a server, so it's not a huge amount. Anyway, so 5 years worth of collocation. I didn't put any internet because you don't really need it. And it costs about 67,000. It looks a lot, right? It's a big amount for something that doesn't even have GPUs, but it's a start. And overall, the cost per token is actually rather large, but it may be sufficient for what you want to do. Now, medium one is better. Right? So here we have 2 NVIDIA L4 GPUs of 16 gig. So you could easily run the 13 billion parameter LLM, which is good enough for most applications. The switches, the storage, everything, basically, and it will set you back $83,000. Again, this seems a lot, but in terms of cost per token, it's only 0.017, which is almost 10 times less than this because of just the CPU. The GPUs per se are more efficient, right? And the same obviously goes if you spend a lot more money and you buy a bigger infrastructure with 3 servers with 2 NVIDIA A100s. This is what you hear about when people do training and use, these are the servers that they are typically talking about, the GPUs that they are typically talking about, which is actually very hard to get. And if you get these ones with 40 gig, they're about $10,000 each. Right, just to give you an idea. Anyway, so you put 2 of these, and a server like this costs about 50K. Right, so only the servers are 150K, and everything else is peanuts. Anyway, so the actual cost per token will be somewhere around 0.002. So again, your mileage may vary, but you see the progression here. Right? So depending on what you want to do on-prem, and depending on what your company needs to achieve, whether you want to offer these services to their customers, for example, if you're a financial institution, you want to offer like this financial assistant to your customers. You do an investment like this, you can offer it to your customers. And obviously you amortize it over time. And you get to keep your models private. If you're training them on your financial data, which may be very important, or your forecasts. If you're a consulting company, right, you want to offer this virtual consultant, and again, you want to keep everything as close as possible. You want to charge your customers probably a lot more than this. Right? The fact that it's an AI will probably be secondary. So it's not going to be this cost that's going to matter to you. If you're, on the other hand, a startup and wants to do something where the cost matters a lot, then yeah, you got to run your numbers and run your experiments and see where you are. But I still think you'll get better at owning your own kit over time than renting from somebody else. Probably not in the beginning. In the beginning, you may want to make sure that you are testing your product and make sure that you actually have clients, paying clients. Anyway, so what does MetalSoft do in this whole scenario? So again, if I have the equipment, one of the big issues and things that you're all thinking about right now is, okay, cool, I'm going to have the equipment, but who manages it? I'm not a network expert. I don't have a network expert. I don't have I don't want somebody to manage it. Who puts it together? So, that's where MetalSoft comes in. You put this agent, which is a VM, it's basically a series of containers, put it in somewhere where there's a management switch that we provided in the list, and that's all you need, access to the management interface. You plug all the servers and the switches, and if you have storage. And it will automatically discover them. It will discover the topology, where everything is connected. It's going to put the operating system on the switches. It's going to configure the switches, the BGP initial configuration, MC lag, and everything. Discover the servers, discover the GPUs, allocate similar server types to similar configuration servers, and then it's going to offer this as a service consumption layer upstream. Right? And we call this, we are one of the only solutions in the market that can operate without any in-band connection. Right? So what that means is that we don't have access here to where the actual data goes back and forth, where your model resides and where you're accessing your additional data. So this part here is air-gapped, or can be air-gapped from this tenant, the in-band network. Anyway, so that's actually a cool security feature. All right, so that's automation, the automation part, and this is the cloudification part. So you have two ways of consuming that infrastructure that you put together, and remember that I told you that maybe the same infrastructure needs to be consumed by multiple groups. Right? So you have this portal, which I'm going to show you in a second. And in that portal, you can drag and drop. You can say, I want 2 servers, one for my vector database and one for the actual LLM, and I want them connected in this way, and I want some storage because that's going to need a lot of storage if you have storage. Anyway, and you hit deploy and you get that, and that is going to be a private network, a private environment in which to do things. But that's one way of consuming it. But most of our customers, they use code to provision it, right? So this is a notebook. So if you're familiar with Jupyter Notebook, you can have the infrastructure provisioning bit in the beginning and the rest of the stuff down below. It takes about 30 minutes to have everything up and running from scratch. And also, when you roll the equipment from the factory, again, there's no configuration required. Just plug it in, and you can be up and running in a very short amount of time. I mean, under a day. Okay, and I think what's very important is that we're scalable. So my configurations have 3 servers, but in many situations, that's just one part of the infrastructure that you're operating on-prem. You may have, N racks, each with different servers and different configurations and different type of workloads and different things. And so MetalSoft handles all of that in all of your data centers. Right? So it's pretty scalable. All right, so what that gives you, I think, is what we call resource mobility. So typically on-prem infrastructure, it has been considered, as opposed to the cloud, very fixed. You deploy it, and then you cannot change it, and because you cannot change it, you cannot innovate, because you don't get access to it very fast. When you have different silos, different environments, they tend to have their own spare capacity, which leads to waste. And it's also very intensive to manage. But with MetalSoft, you can build this common pool of resources, right? And you can shift resources from one silo to another, from one project to another, one tenant to another, just like you do in the cloud. right? So you get better utilization overall. All right, and you also get security with that, because each individual tenant will have its own security zones, right? So its own VLANs or EVPN tunnels on the switches, so that they only see their own infrastructure, they don't see anything else. And infrastructure as code. If you're used to working in an infrastructure as code type of environment, you talked about it before, and a lot of companies do that, and they're starting to do that with LLMs as well. You will want to have, two sort of stages. You want to provision the infrastructure, put the LLM on the machine, run your tests or whatever you want to do, and then decommission it all as part of the same pipeline. Right? So you can have a dev environment, you put one pipeline, production environment, you push to the dev environment, it runs the tests on the model, right? Does it work? Doesn't work? It outputs correct output or not? And then if it does, then you promote it to production. Right? So you can do that. You can tie the bare metal into your existing pipelines, if you have them. Or you could build them if you don't. Okay, that was the last slide. So I'm going to show you a bit about our product, and also I'm going to run Llama 2 on a P100, so you can see how fast it is. But before I do that, or while I'm waiting for my screen to load, do you have any questions?
Let me...
So the question is, how does it handle failures?
Yeah, you have a rack, you have multiple hardware components, and in case they fail from time to time, it's
they do fail many times. That's hardware, So we have very robust mechanism for handling that. So I haven't talked about it, but we do also monitoring. So we monitor all of the equipment, the servers, the network. So if a hard drive fails or if an entire server fails, we get a notification. And that is aggregated into a stream of events. And you can tap into that. You can have your NOC team monitor that. Right? So if there's a hardware event, you get to choose what you want to do. You want to provision another server, click a button, provision another one, and it works. But obviously, your application layer will have to be able to support that, to be able to add another layer. You could have Kubernetes on top of it, because this is bare metal, right? You can have your whatever you want on top of it. In the LLM world, you can kind of run everything directly on, don't need anything fancy like Kubernetes, but, maybe in your environment, you want to do Kubernetes. So you handle failures that way. So it's not necessarily our job to handle them. The hardware has failed, but we notify you. And we can work with the upper layers to provision additional resources from a common pool of resources. Like, for example, there's a cluster API plugin to Kubernetes. So Kubernetes can request another server from us. So we're basically like a cloud provider on-prem for bare metal. Any other question? Please. No, just pick it. I'll repeat it.
Here.
Okay. Oh, I'm sorry. I didn't see you there.
Okay, nice presentation, very interesting product. I want to understand if the application layer have to be aware about the hardware model which MetalSoft offer to the applications.
That's a good question. So the answer is not necessarily. It depends on your workload. I think in the LLM space, you need to know what GPU you have, because you need to marry your model size with the GPU, because it's just not going to work without it. It's just going to throw GPU out of memory error, so you need to know. But the way we handle that is just what we call server types. So your application layer is going to say, I want M13.4.1, which means a server that has one GPU and this amount of RAM, and it's going to get it provisioned. So it has knowledge. It doesn't have knowledge about what vendor it is. This is a multi-vendor solution. Doesn't have knowledge about the actual, the network configuration or anything like that. So it has some knowledge, but not hardware knowledge in the true sense.
Not specially designed for this model.
That's right. That's right. So this is an abstraction layer from that perspective.
Okay. Thank you.
I hope I answered your question. Okay.
It was another question there.
Yeah, please.
You have already answered, but my question was about the number of vendors, the pool of vendors you're supporting, because I would expect that this kind of behavior would require some internal APIs and a lot of maintenance. And
Yes, it is very, very hard to build. So we built it from scratch. We built the drivers from scratch for all of the vendors that we support. And I think I have a slide here about the vendors. Well, basically, we support all of the major vendors. It's not, they're not all listed here. But I can tell you this Dell, on the server side, there's Dell, HP, Lenovo Supermicro. On the switches side, it's Cisco, Cisco ACI, Juniper, Cumulus, Dell OS 10, and Dell Sonic. And on the storage side, there's Dell PowerMax, Dell Unity, we're adding support for Dell PowerFlex. There's an HP MSA, and then there's a NetApp that we're working on. So we have a relatively large slate of,
pretty
support
good
already.
coverage.
Yeah.
And the second, I don't know, it's another question. The other question was, you said something about using BGP for routing. Why do you use BGP? Because that's designed to be externally
Well, it's
used.
not that external, actually. It's a very good question. So when you build a multi-tenant environment for a network, and this is a parenthesis, I'm mindful of time, but I think I will have time to run this. Actually, maybe I will run the LLM while I'm answering your question. Is that okay? Because it may take some time. So I have a server here. And I've already downloaded my Llama. And I'm going to start the completion for it. And I'm going to time it. And it's going to throw an error at the end, but don't worry, that's actually working. I'm going to show you what it is. Anyway, so hope, you can't see anything. Can you see now? Okay, so, actually I'm going to also open another one. So this is Llama 7 billion. Running on an NVIDIA P1, which I'm going to show you in a second how it looks like. So it loaded the model in 11 seconds in the RAM, and this one is going to connect. And then now it started to actually do the inference. This is not working yet. So we'll connect to the server, and I'm going to show you. But it should be ready in about a minute or so for one prompt. Okay, so getting back to your question, BGP is used to separate, not BGP, but EVPN is a technology for separating tenants or creating these private networks within networks. Layer 2. No, yes. Because in most environments where we work with, banks in particular, they want to protect broadcast against broadcast traffic and impersonating other clients. And doing protection at layer 3 is actually more complicated because it means inserting either a firewall between tenants or doing some fancy ACLs, which is not that, it's not supported by all switches. Anyway, so BGP is used as part of EVPN to create those segments. It's the way switches communicate with each other and announce them, hey, I have this new tenant and it has these networks. And there's another one, I have this. So it's a way of signaling, of transporting the information about the layer 2 overlays. Anyway, so for everybody else, it's a way of segmenting infrastructure. Okay, so my model has finished and I got an output. The question was, what is the receipt for mayonnaise? And mayonnaise is a fake creamy. Then it took 1 minute and 22 seconds. Trying to SSH back to see but you won't see anything on the NVMe, on the P100s, just that it worked. All right, so let me show you a bit about around the application. So imagine you have this rack, you bought it, and you got delivered, and it's in your data center, right? And or maybe the equipment in the rack, and you plug the equipment in the rack, and you cable it, and that's it. You step away, you go back to your home, and then after a while, meaning around 30 minutes or less, your admins or you yourself will see the rack in this left-hand interface here, which is our topology view. Right? So you'll see the servers. Well, you'll see something. That looks like this, which is your pool of resources that your different tenants, your different team members can use. Right? And they're shut down. They're not doing anything. They're just waiting there and waiting to be consumed. Right? So I have some of them. These are the server types that I've told you about, if you remember. You have servers with identical configuration will get allocated the same server type. Like this one, M1281. Anyway, when the server gets detected, we also detect where it's connected in which network port. So this server is connected to this switch on this switch interface. I know you don't see anything there, but trust me. Same on the switches side, same on the server side. And basically, you don't have to do anything here. You can, though, configure how you want the layer 2 networks to be created, how you want the IPs to be allocated, what is the subnets from which you want to allocate IPs. So it can be very fancy and complicated network infrastructure because the solution is designed for whole data center orchestration, not just this particular use case. But for a simple setup where you only have a rack, it will just work out of the box. Right? Okay, and then you have some templates that you get from us or you develop them yourself. We do something very interesting here when we deploy the operating system. We get the standard ISO, let's say the Windows ISO or the Ubuntu, and we inject configuration files in it for the particular server that gets deployed. And then we attach the ISO to the server that we want to deploy, and the server goes through the installation process unattendedly. That's how we do it fully out of band, and we don't need anything fancy like Pixie. Anyway, so that's how we do the deployment, and then after that, we also do the actual provisioning. Anyway, so on this right-hand side interface here, this blueprint editor, as we call it, you can define how you want the infrastructures for each application to look like. So, or you can actually consume servers. So I have 2 servers here, and I want to add another one. Right? I do a drag and drop, and I want a server with the GPU for my Llama model. Select the server from the available server types, like you do in Amazon when you select the instance type. Right? You say, I want to install the OS on local drives, and say ESXi, or Ubuntu in this case, which is what I used today. Click Create. 3 minutes. Okay. Anyway, so I have the server. And I don't want it like this. It's only connected to the default network. I want another layer 2 connection to my vector database, which may be residing on the other server. Right? And I do something like that. And also maybe I want to add some storage. I didn't put any in the previous slides, but many companies have storage for this kind of purposes. One of the reasons why is because these models are so big, 140 gigabytes, you don't want to copy them all the time. So what you can do is you can just attach them. You can attach the storage to the respective machine that you want to use it to work with. So this can be detached from a server and attached to another server. Anyway, so that's one way of operating. Other ways of operating would be to use some object storage that you may have on-prem if you have one, or some NFS or some other mechanism. Or you just copy the model like I did, just download it from Facebook and put it on the local drives. Llama to 13 billion. So I'm showing you how it looks like. So this one is 13 gig, so 26 gigs in total. The Llama 13 billion. So I did not download the 70 billion one because I don't have enough GPUs. So this is the GPU that I have. Oh, and what I can show you maybe in the last minute that we have is this GitHub pipeline that uses Terraform to deploy the same thing. So I'm going to switch to another infrastructure. That's pipeline controlled. And I'm going to try to do a change and alter the pipeline. So this is the Terraform manifest. If you've used Terraform, you're familiar with this. If you haven't, Terraform is a way of provisioning cloud infrastructure. Right? So you It's agnostic. You use it in more or less the same way for multiple cloud vendors. So you can use the same with your new bare metal cloud that you have on-prem. And so this is the manifest. And these are the servers. You have a server 1, as you can see here, server 2. And I can add another one. Code is read-only. Okay, edit. Server 1, server 2. I'm going to put a server 3 here. Test 3. Commit changes. And we wait. Actions. We have 30 seconds. Let's see if we're going to see it in the blueprint. So it's going to do some things here. Well, why I'm showing you this is because, again, if you want to build a pipeline, real development pipeline for LLMs, you may want to incorporate the infrastructure into that. If you do, then it's going to look something like this. If you don't, and you just want to provision it from your notebook, you can also do that. So it's crunching some stuff here, trying to detect the change that we did. 0, 0, 0. So it's going to be ready in 30 seconds, I think. Don't kick me off. Not yet. Please, Mr. Terraform. Move faster. I'm going to try to zoom in because you're only seeing squiggly lines.
Meanwhile, you can prepare your questions.
Yes.
I feel like a small language model with no GPUs, so I'm not going to ask any question. Okay, so we have a few more minutes for a few questions. So
It popped up.
okay.
That's
So yes, there is a question there.
Ready.
Hello. So it wasn't very clear for me what MetalSoft is doing. So you sell the system for me to manage my own data center, or you also sell part of a data center you manage?
No, so it's for you to the first version, for you to manage your own data center
so
privately.
it's my hardware, only my hardware.
And your software. You run your software in your data center. You download the controller, and you run it in your data center.
Okay, I get it. Thank you.
So it's like VMware. If you have VMware and you use it to provision VMware, the same, except it manages physical hardware.
Okay,
And it works with VMware and Kubernetes.
thank you.
Okay, any other question? If not, thank you very much, and we'll discuss it over the coffee break, which is going to be
Coffee, yes.
20 minutes.
Coffee. Okay,
Thank you.